On behalf of the Energy Systems Lab, I want to welcome you all to CATEE and thank you for coming. It's certainly, I find it to be exciting and invigorating every time I come here each year. And it's something that I certainly appreciate the work that Bettine and Bauman and all of the others on the committee have done in putting it together. And I trust that each of you will find it to be a good use of your time as well. Today I want to give you, I know many of you are familiar with the lab, but some of you I'm sure are not, and so I want to give you a little bit of an overview of what the Energy Systems Lab is, because we're not we're not really a typical university laboratory. Now let's see if this thing operates the way, no? What? Oh, here we go. Here we got something. Maybe if I push the right thing, what'll happen? There. Okay. We're basically an applied research lab that, we focus on energy efficiency, but, Oh, it's too loud. Okay, we'll hold it down. Is that a little bit better? Okay. But we do an awful lot of very applied things, and in fact such that we tend to view ourselves as being something of an engineering teaching hospital, because we do a lot of projects that really are areas that research funders don't tend to put a lot of money into, and so we'll provide an engineering service and get our students involved in much the same way that medical students get involved in university medical centers, but we'll have staff engineers that are leading out so that people are getting a good engineering service, and at the same time that we're doing that, we end up getting the students involved in their research projects where they end up improving the technology while we're doing it. And so it's sort of, we view that as being a win for the students in the opportunity they have to do something practical, and it ends up ultimately being a win for the employers who end up hiring students who have gotten some practical experience as part of their educational process as well. We certainly work to develop innovative technologies, and we're very much interested in commercializing things. The continuous commissioning that we have done for years is something that has been commercialized. And fundamentally, aside from the faculty that are associated with the center and the funding that we get from the university as part of, for our teaching and things like that, we're entirely funded by contracts for research and services. So, we do not get any appropriations from the state that are directly just to the lab as a part of the university. Now, there is, the work that Jeff is going to be talking about is funded by the state as a mandate for work that they have mandated us to do. But in general, we have to work to eat. So I just want to talk today about two particular aspects of our operations that are somewhat new and interesting. Jeff is going to be talking about the, certainly the TERP work later on, right immediately. Brian Rasmussen will be talking about some of the Industrial Assessment Center activities this afternoon, and of course yesterday there was a continuous commissioning workshop. A&M is going to be starting a new undergraduate degree program in architectural engineering, and that will be followed by graduate degree programs. And many of you probably aren't aware, but basically a mechanical engineer, generally speaking, when they come out, is very poorly prepared to work in buildings, because they might have had one or two courses that are directly related to buildings or energy efficiency. An electrical engineer, when they come out, is even more poorly prepared to do anything in buildings. In fact, we've looked at the curriculum, and there's not a single course in the electrical engineering curriculum that is directly relevant to someone that wants to work in buildings. There are about 20 architectural engineering programs around the country that basically educate engineers to work on different facets of the building construction and operation process. And A&M is committed to starting one, and we will plan to offer specialties in mechanical and HVAC as one specialty, in electrical and lighting as another specialty, and then sort of a very standard structures specialty as well. It will probably start for first enrollment of freshmen next fall. It's a little bit up in the air yet, just because we have just hired a program coordinator. He came to work a month ago yesterday. We're very fortunate in the individual that we got, Dr. Murad Atif was previously the general manager of the construction research program at the National Research Council of Canada. There he directed a group that is, I think, the largest single research program on construction in North America. They have about 400 people there. And he was primarily responsible for taking that program from what was essentially a government-funded research program to one that's over 50% funded by industry. And so as such, I think it's probably the largest industrially funded program in the construction industry in North America. So he has a lot of ties to architectural engineering, to the construction industry, and to knowing, what is happening that needs to be done. And we are very firmly committed to building this architectural engineering program to meet the needs of the industry in Texas. And if any of you are interested in getting involved in that process, we've had some workshops where we got input from folks on what they need in engineers coming out as far as curriculum. That will be continuing, and so anyone that's interested in that, please talk to me afterwards or whenever you get a chance. On another topic, something that's very interesting that we're doing at A&M now is that we are developing a completely new type of air conditioning. It basically operates on very different principles from current air conditioners. Those of you, when you make a pot of spaghetti and you want to get the water off, you typically pour the spaghetti and the water into a colander, and the water is sieved out of the spaghetti. Now, if you stuck that colander in a tub of water and you poured the water and the spaghetti in there, you wouldn't get any water out of the spaghetti. Well, this basically operates the same way. We've got a membrane that lets water vapor go through it. It basically doesn't let air go through it. And so as long as we get the water pressure on one side of it low enough, it'll just pull the water right out of the air. Literally, if you pass very moist air through along about this much of that membrane at typical speeds for air going through air conditioning systems, it'll take half the water out of it. And it does this for the picture we have up there shows, it actually is a micrograph of that membrane. The actual active part of the membrane is only 2/millionths of a meter thick. So it's very thin, but it has to be supported by something thicker then to provide some mechanical stability. And so that is a picture of it, and then schematically it just has all these little holes in it that are basically molecular size, and so the water vapor molecules can go through them. And I won't go any further than that in terms of explaining how it operates. So fundamentally, we have a way now of doing air conditioning that does not use any refrigerants that have any impact on the environment or otherwise. What in the picture you show, basically you've got, if each of those sort of pinkish sheets, if you were to imagine having a membrane on both sides of each one of those sheets, and then you just pass air between them, then the water vapor gets sucked out between the sheets and removed, and then eventually gets taken up and condensed into water. And actually you have very pure water now because it has gone through these literally molecular size sieves so that bigger things can't get through it. If you think about a particle of dust would be like a mountain compared to the size of the holes that the water is going through. And then you can simply cool it however you wish, whether with mechanical cooling or whether with evaporative cooling or whatever. Another way of looking at it is that it's a way that we can actually end up drying air well enough that you can use a swamp cooler in Houston. If we look at where it is, this is an air conditioner here that isn't big enough to cool your house. This is what has been built and tested, where basically the testing verifies that it works as we expect it to work. The next phase is to get something that actually looks like an air conditioner, and we're just in the process of getting the funding in place from the Advanced Research Projects Agency at the Department of Energy, and the Department of Defense and the Navy have also committed funding to it because the Navy is interested in using sort of the first commercial versions of this technology to help dehumidify some of their cargo ships. And they're committed to that. And we also have another very large customer that's interested in using the technology to provide dehumidification in data centers, where they're now using evaporative cooling to cool data centers. And so we think that it has a tremendous potential to change the air conditioning industry over the next 20 years because it fundamentally changes the way that we dehumidify and cool air in combination. It will completely eliminate the need for any of the refrigerants that have adverse environmental impacts, and it will be more efficient than current technology. Along the way, it's going to generate highly pure water, and just this morning I noticed an RFP for an entity that's interested in that aspect of things, and so I'm sort of thinking about that as we go through the conference today. And ultimately, we believe that it will either be cost competitive or cost less than current technology. So we're very excited about it. We think that it's going to have tremendous impact down the road. There are a couple of startups have been started to help commercialize the technology, and we'll see where it goes from here. But with that, I think I'd just like to remind you that the Energy Systems Lab, while we're a small organization, we have had impact a lot of different places. Every one of these little dots on here represents a place where we have either had a project or a workshop or have a customer that has provided the equipment to us to test. And so you see, while we're heavily concentrated in Texas, we have had activities in over 40 of the 50 states and in about a dozen foreign countries. So with that, thank you very much for being here, and I'm going to hand it off to Jeff to get you up to date on what's going on in Texas on energy efficiency and environment, and I guess the reason for CATEE, right?